Okay, guys, I wanted to do one more of those midpoint examples. And this one's just phrased a little bit different. This one says, find the coordinates of the other endpoint. They call it Q of a segment with endpoint -9, and midpoint -7, 6. So this XY, this is the Q I'm talking about. So I have -9, okay? That's this point here. Here's the midpoint, -7, 6, and I want to know what this point is. Well, we can just kind of move it around. We know that our midpoint formula is this. The midpoint is equal to x1 plus x2, the average of the x's, comma, the average of the y's. So we know the midpoint is -7, 6. So that has to be equal to, if I consider this my x1, comma, y1, right here, this -9, 9, and this is going to be -9 plus some x value, that's the x value I'm looking for, over 2, and 9 plus some y value over 2, that's the y value I'm looking for. So really we get two sort of equations you could think about as. For the x, we know that -7 is equal to -9 plus x over 2. And we also know that 6, this is for the y, is equal to 9 plus y over 2. So I have to solve these. -14 is equal to -9 plus x. I just multiplied both sides by 2, and then I add 9 to both sides. If I add 9 to both sides, then what I'm going to get is -5 is equal to x. Now I'll do the same. 12 equals 9 plus y. Okay, that's fine. Subtract 9 from both sides. Y is equal to 3. So that midpoint, not the midpoint, that Q point, okay, that we end up getting, that other endpoint is -5, 3. And that seems reasonable based off of my picture up here. -5, 3, looks like I drew somewhat decently. Okay? So that's if they kind of move the question around. Just think about it. Now it's just you have to solve two equations. The other thing I wanted to talk about in this section was right here. Graphing linear equations, which I'm quite sure you've seen this before as well. But just as a quick reminder, okay, now remember when we talk linear equations, that means x is to the first power. And these, of course, they are in two variables. Okay, maybe I should mention that. Remember in the first chapter, all we would do is we'd be dealing with one variable, we'd be solving it. Now when we have two variables, now we can actually get these XY graphs, right? So it just gives us a relationship between two values, generally X and Y, but you can think about this in any case, like a business, you know, maybe the X is the years, the Y is the profit in millions. That's a pretty good business. And so what I want to do is I want to remind you on how we can graph these. So one of the ways, I'll call it the first method, is to use the y-intercept and the slope. And the thing to remember here is this little thing here. Y equals mx plus b. I'm sure you've probably seen that before. Where m is your slope, right, which we know is rise over run. And where b here says that your y-intercept is at 0b. It's important with the y-intercept to remember that it's actually a coordinate. You don't want to just put, oh, it's just b, right, because it's a coordinate on this graph. So if we look above, we see that the slope, in our case, m is equal to 2, which 2 is the same as 2 over 1. So it rises 2 and runs over 1. And our b is -3. That tells me I have a y-intercept of 0, -3. That's where I usually start. So if I go to 0, -3, that's right here. Okay, 0, -3. Now remember, these are linear equations. That means their graphs look like lines, a straight line. How many points determine a line? You need 2. I got one right here, 0, -3. Question is how do I get another one? Well, I use my slope, 2 or 2 over 1. That tells me the rise is 2, the run is 1. I know that's another point on the graph. That's 1, negative 1. And I could even find more. I could go up 2, and I could go over 1, and I see that 2, 1 is also on here. So I can plot as many as I want, but I really only need 2 of these. And that will give me my graph, okay? You always want to put at least 2 points on the graph, okay? So we know to see, okay, is that slope correct? Okay, so that's the first method. The second method is a little more handy when you have the equation that looks like this. This is what we call an implicit equation. It's not solved just for y or just for x. In this case, it's generally more handy to use x and y intercepts. And what I mean by x and y intercepts is x-intercepts are where we cross the x, and y-intercepts are where we cross the y. So a linear equation generally has one x-intercept and one y-intercept. It is possible they have neither if it's a vertical or a horizontal line, okay? But in a case like this, when it's implicit, here's how I would do it, is I would say, okay, well, let's find the x-intercept. And what you want to think about with the x-intercept, that's right here, what is the value of y, okay? Well, I know here the value of y is 1. I know here the value of y is negative 1. So in between, it must be 0. So x-intercepts are when y is equal to 0. That's when we cross this x-axis. So what I'm going to do is I'm just going to plug in y equals 0. That means 3x minus 2 times 0 equals 6. 3x equals 6, or x is equal to 2. So that tells me I know that I'm crossing this when x is 2. And of course, if x is 2, y is 0 if it's the x-intercept. Likewise, for the y-intercept, okay, if we look at this, that's when we cross here, that's when the x is equal to 0, okay? So if I let x be 0, that means that 3 times 0 minus 2y is equal to 6. Negative 2y equals 6. Y equals negative 3. So I know I'm crossing the y right here at 0, negative 3. Got 2 points. That determines a line. My equation is linear. So I will connect the dots. And we do put arrows on the end just to show, well, it does keep going forever. Okay. So do know how to find x and y intercepts using this method here. I might ask that on a test. Hint, hint. One last one I want to look at is graphing a nonlinear equation. Now, we're going to have better ways of graphing this fairly soon, but for now, for this method, let's just plot points, just pick points. So we can do that by making an XY table. And what I want you to notice is if I try to put in, say, x equal to 0, I get the square root of 0 minus 3, which we know is something imaginary, meaning it doesn't show up on the graph. So this is no good. Same thing if I try 1, square root of 1 minus 3, that's no good. If you think about it, the smallest value of x I can use to actually get a real number and have it show on the graph is the number 3 for x, because then I get the square root of 3 minus 3, square root of 0 is 0. So I have the point 3, 0. So I'll go over here, I'll plot the point, 3, 0. Let's try when x is 4. Square root of 4 minus 3 equals square root of 1 is 1. So I have the point 4, 1. Now here's the thing, you need more than 2 points if you have a nonlinear equation, which this is, right? We know this is technically x minus 3 to the 1/2. That's nonlinear, okay? So it's not going to just look like a line. So generally you want to get a few more points to get the feel of what's happening. Now I'm going to pick a convenient value of 7. Try to think why I picked 7. The reason is if I put this in 7 minus 3, I get square root of 4. Oh, that's something I know. That's a square root I know. I know the point 7,2 is on here. So 7,2 is right here. And I could keep going, but I think you can kind of see what's happening here is it's going like this, and it's going to go up slower and slower and slower, and you can see from the graph this is nonlinear. Okay, so do know how to plot some points and try to get at least a general shape of what it looks like. Your other option, of course, is to go through and use your graphing calculator. Okay, if you do want to see an example of that, please let me know. I can make a video of that. Okay, all right, that does it for 2.1.